Okay, graphing the sine and cosine function. When you're graphing the sine and cosine function, all you're going to do, and we're going to start by just graphing the sine function, so sine of theta. So y is going to equal sine of theta. All you're going to do is use the points from the unit circle at your key angles. In other words, our key angles were 0, pi over 2, pi, 3 pi over 2, and ending with 2 pi. So we're measuring the angles in radians, and then we're getting the points at those angles. The first angle, the points are 1, 0. The coordinates are 1, 0. Then you have 0, 1 up here, negative 1, 0, and 0, negative 1. So if you remember back to when you first learned how to graph, you made a table of values, and then you plotted those values. So if you think about this as an XY table, where your X is your angle theta and your Y is the sine of theta, then you can just go through and get the sine of each of these key angles. So our first key angle is 0 radians, and if you remember, sine is always the y coordinate at that point. So at that point, 0 degrees or 0 radians, your y value is 0, so your sine is 0. Going up to pi over 2, which is our next key point, the y value is 1, so the sine of theta is 1. And just keep going around to get the y values at each of these points. And at 2 pi, your y value is again 0. So if you look, you kind of repeat through a pattern of numbers. You start with 0, go to 1, back to 0, down to negative 1, back to 0. This is called a periodic function, and that is one period or one cycle of this function. And then when you have to graph the function, you're going to take your x-axis, which is now your theta, and your y-axis, which is now sine of theta, and plot those points. And so you start at 0, so 0 radians, and we know that our maximum value is 1, so we really don't need anything more on the y-axis other than the 1. The highest you're going to go is positive 1, the lowest you're going to go is negative 1. At the end of the x-axis is one period, which is 2 pi. The end of one cycle, you've gone through 2 pi radians. And then we're just going to plot in between there. Halfway is pi, half of that is pi over 2, and half of this section is 3 pi over 2. And I'm just going to plot those points in between. So at 0, my sine is 0. At pi over 2, my sine is 1. At pi, my sine is 0. At 3 pi over 2, your sine is negative 1, and back to 0. So if you look, we have a curve that looks like that. Now, if I kept going to the next angle after 2 pi would be back up to pi over 2. The reference angle would be pi over 2, and that would be 1. So you'd be going back up here again, and then you'd be back to 0. So if you look, you're going to have sort of a wave, is what we call it, a sine wave. And you could do the same thing going backwards. So if you went backwards, you'd end up with a wave going that way. Okay, so to graph the sine function, no matter what the sine function is, you would have to know your amplitude and period, the height of the graph, and how long it takes to go through one cycle of the graph. So the sine curve is a graph of a sine function. And you can identify it by the amplitude and period. Okay, the amplitude is the height of the graph, and the period is the horizontal length of one cycle. One cycle through, so from the 0 back to the 0 all around the unit circle, that's one cycle. So the graph of y equals negative 3 sine 2x is the graph we want to graph. X is measured in radians, so x is your radians, just like on the graph we just did. And the sine of 2x, we want negative 3 sine of 2x using x as our angle. What are the amplitude and period of this? Well, when you graph it, you can see the amplitude goes up here. That's the height. So that would be 3. And it's going to be whatever the number in front is, right? Only this is negative 3. So how did we get that 3? Well, we just took the positive value of that distance, which is 3, which is also the definition of absolute value. Your period, the period of this one is here, because that's one cycle, which means my period ends at pi. So the period of this function is pi. Okay, notice that I could go through this cycle how many times from 0 to 2 pi? Well, I went through it once here and once again here. So actually this one goes through its cycle twice in the from 0 to 2 pi on this graph. So to get the period of any graph, you're just going to take that 2 pi, divide it by whatever that b is in front of your theta. That will give you your period. That number tells you your period. Amplitude is the absolute value of the number in front, because remember, amplitude is a height, and that's always going to be positive. Okay, so we're going to use those formulas to find the amplitude and period of these sine functions. So for number 1, a is 1/2. Amplitude is absolute value of 1/2, which is just 1/2. It's just the positive value of the number inside the brackets. In this problem, b is 3, so the period would be 2 pi over b, so I put a 3 there, and this just equals 2 pi over 3. You can't reduce that. Okay, so what if I have a fraction here? How would I find the amplitude and period of number 3? Well, the amplitude comes from a, so the absolute value of a is the absolute value of 4, which is just 4. So the amplitude is easy. A period is going to be 2 pi over b. Well, in this case, b is this whole thing right here, 4/3 pi. Okay, first of all, we know that the pi's, when I divide those, that equals 1, so I can cross those off. So now I have 2 divided by 4/3. And if you remember how to divide fractions, you just do keep, change, flip. So 2 divided by 4/3 would be the same as 2 times 3/4, which would just be 6/4. And that reduces to 3/2. So the period of this function is 3/2. Go ahead and try the rest of them. The answers will be on the notes that I post on the wiki. The next thing we're going to do is actually graph a sine function. So let's look at the graph of this sine function, y equals 2 sine 1/2 theta. In this function, a is 2 and b is 1/2. So that means my absolute value of 2 is 2. That's my amplitude. And 2 pi divided by 1/2 is just going to be 4 pi when you work it all out. So the minimum and maximum of this curve come from my height, or my amplitude. So the maximum is just going to be 2. The minimum is going to be negative 2. Just the opposite, two opposite numbers. Okay, the y values, if I think about it, are going to go through a pattern similar to the one we looked at in the beginning example. Only now my angles here are going to be different. So I always start at 0, and my last angle is going to be 4 pi. Now I need all the angles in between that, because I have 0, 4 pi. Remember, you have 3 angles in between there. Well, half of 4 pi is 2 pi, so I know one of my angles is 2 pi. And then half of this one is pi, so that'll be this angle here. And then this would be the angle between these two. You can either multiply this one by 3, because it's 3 of whatever that angle is, or take half of the distance between these. Either way, it's going to be 3 pi. Okay, now I just need to know the numbers. Well, I know the sine of 0 is always 0. In this case, the sine of the pi at pi, it's going to be my maximum, because if you go back to the original one we did, the second number was your maximum, the third number is 0, the next number is minimum, last number is 0. So the maximum is 2, back to 0, down to your minimum, back to 0. So we use a pattern like this: 0, max, 0, min, 0 to graph it. Alright, so if I were to graph it on this graph right here, I know there's not a lot of room. You have your max and min, and you've already got your angles on there. So if I were to plot my points, I would be at 0, 0, then 2, at pi it's 2, at 2 pi it's back to 0, at 3 pi it's at negative 2, and back to 0. So you just draw your curve in. Okay, so when you're labeling this, remember I labeled the x-axis using the angles, and I labeled the y-axis using the max and min. Okay, so you're going to try the 6 problems here, 7 through 12, and check your answers on my master's notes that I posted on my wiki page. The only difference between sine and cosine is it's still a curve. Cosine is still a curve. However, if we go back and do y equals cosine theta, remember if you're graphing it from 0, theta and cosine theta, you would have 0 for your first angle, but now the cosine, remember your unit circle, the cosine at this angle right here is the x value, so that would be 1. Remember, this is 0, 1, negative 1, 0, and 0, negative 1. So then at pi over 2, my cosine is 0. Pi, it's negative 1. 3 pi over 2, it's 0. And at 2 pi, we're back to 1 again. So the pattern changes a little. We start with 1 and end with 1 instead of with sine, the first one's 0. So when I graph it, I'm starting with the max, right? Then 0, then the min, then 0, then the max. So the pattern, whoops, went the wrong way. The pattern, you're going to find all this stuff the same way up here. Down here, your pattern starts at max, goes to 0, then min, 0, max. Now, something I forgot to say when we were doing sine, but it applies for both of these. Whenever it's negative, whenever a is less than 0, the pattern switches. Because remember, in any function, for instance, a parabola, this is the parabola of y equals x squared. But when I do y equals negative x squared, when this number in front is negative, that parabola flips upside down. The same thing happens with a sine and cosine function. So you've got y equals negative cosine x, then this is going to be min 0 max 0 min. So it just flips, just like the parabola flips. So let's do this problem. Y equals 3 cosine pi over 2 theta. Okay, so if I'm graphing or if I need to graph this, I need the amplitude or to get my max and min. So my max is going to be 3 based on this number, and my min is going to be negative 3, just the opposite of that number. And period is going to be 2 pi over b, which is pi over 2, which is the same as 2 pi over 1/2 pi. So now these pi's go away, and if I keep change flip, this just equals 4. So my period for this function is 4. So let's make a table. Okay, so my theta is going to go from 0 to 4. Well, it's pretty easy to get the numbers in between this. It's just going to be 1, 2, 3. So if I use my pattern, I know I'm starting at my max, so it's 3, then 0, then min, then 0, then max. Okay, this is a positive function, so I can use the standard pattern. Then draw my graph. So I have my y-axis with my amplitude, 3 and negative 3. My x-axis, 1, 2, 3, 4. And then just plot your points. So at 0, I'm at 3. At 1, I'm at 0. At 2, I'm at negative 3. At 3, I'm at 0. And at 4, I'm back at 3. So the graph will look like this. Okay, so the next thing you're going to do is do these 6 problems after that. So 1 through 6. So the assignment for today was to do both 1 through 6 on the cosine. And then for the sine, I believe the numbers were 7 through 12. Do all 12 of those problems for your assignment. And I won't put the answers to those up on my wiki, but I will put the completed notes for you.